Okay, so in the last couple presentations, we've been looking at how firms should choose the cost minimizing combination of capital and labor to produce a certain amount of output. And so today we're going to be looking at how does that optimal combination of capital and labor change if some other part of the scenario changes. So like we're going to look at what happens if wages go up or down. How does that affect the optimal combination of labor and capital? What happens if there's an advance in technology so that one of the factors you're using becomes more productive? What happens if you want to produce more? So you were producing a certain quantity, but you want to expand your business. So let's get going. We're only going to be looking at graphs. In this one, we're not going to be doing the math to find the optimal bundle. I'll leave that as an exercise for later. Okay, so the first thing we're going to look at is a change in wages. So just make sure we know labor is on the horizontal axis and capital is on the vertical as usual. So labor, capital. So we start at point A, and wages go down in this scenario. So what's going to happen is, remember the slope of the ISO cost line is W over R. So what's going to happen here is the cost of labor is going to go down, so wages are going to go down. And so that changes the slope of the ISO cost curve. So we're still going to, if we only used capital, we would still be at 20 units of capital. But now if we only use labor, not again. Okay, good. I see which button I pressed. Okay, so if we only use labor, instead of 10 units of labor, we'd be able to afford 20 because the wage rate, oh, that's going to be a problem, got lower, so we could afford more labor if we only wanted to use labor. So if we were still going to produce the same quantity as before, if we were going to stay on the blue Isoquant, so on this Isoquant, we would end up, our point of tangency would shift to B to match the new W over R, the new slope of the ISO cost line. So if we were going to produce the same output level, we would shift our mix of capital and labor from A to B. Notice that at B we're using more labor and less capital. That makes sense. Labor got cheaper, so we're gonna give up some capital and move towards the input that's cheaper now. So it makes sense that we are substituting towards labor and away from capital when wages go down. And then, however, because wages went down, our budget can go further. So even spending the same amount of money as before, we can produce more. So in addition to substituting towards a more labor-intensive production combination, so using more labor compared to capital, we're also going to be able to shift outwards to a new level of production, which is represented at point C. So we end up here at point C, where we are using a different mixture of capital and labor. So the ratio of labor to capital is greater because we're using more labor relative to capital because wages went down. And we're also able to afford to produce more. So notice that A and, so this is similar to the effects we saw with the income substitution effect on the consumer side. Here, the change in the ratio of labor to capital is like the substitution effect, and then the increase in production is like the income effect. Okay. Okay, so this is going to show what happens if there's an increase in the productivity of your input. So a concrete example of this would be like, a new type of computer comes out that's more powerful, it can do things faster. And so with the same amount of labor and capital, you are able to produce more. So an increase in productivity causes the isoquant to shift towards the origin. So we're starting at A. So the key thing to notice here is that in this case, the blue isoquant and the orange isoquant represent the same level of output. So this is the key thing to understanding productivity increases. So what happens, we start at A, inputs become more productive. So now I can produce the same amount of output. So this is the same amount of output. So the increase in productivity shifts the isoquant inwards. So now the orange isoquant represents the original amount of output, but I can produce it at a lower cost. So we are on a lower ISO cost line because since my inputs got more productive, I can produce more with the same amount of inputs. So notice that the slope of the ISO cost line hasn't changed at all. The original ISO cost line is parallel to this one. That's because neither the wage nor the rental rate has changed. God, they're both hard to say. Wage rate, rental rate. So it's still the same slope because the wage and rent haven't changed. But you can produce the same level of output at a lower cost. So that's what technological advances do on the supply side. Okay, so this is looking at what happens to a firm as it wants to expand. So again, we're going to start at point A in this diagram. So we start here. And then what happens is, so let's say over time the firm becomes more and more popular, so they want to produce more and more. So, maybe when they start, they are producing a quantity of 10. And then in the next year, they want to expand their output to 30. So now they want to reach the purple isoquant. As long as the wage rate and the rental rate don't change, the ISO cost lines are all going to be parallel to each other. And so the point of tangency is going to move from A to B as you expand production. And then as you expand production again to point C. This might be they move up to a quantity of 50 or something like that. This increase in expansion and production is going to be important for deriving cost functions, which we're going to do in the next presentation. But you can see from here, you could figure it out if you knew the wage rate and the rental rate. You knew, okay, in the first year, this is how much labor I'm going to use, and this is how. So here's labor and here's capital. And then in year 2, I'm going to use this much labor and this much capital. And then in year 3, I'm going to use this much labor and this much capital. You could compute the total cost that you're going to face in each of those time periods as you expand out, because you know the wage rate and the rental rate, and you can just multiply by how much labor and capital you're using and get the total cost of each one. So that's where we're headed with this. So that we can see, okay, if we want to produce this amount, eventually we're going to end up with a function where, if you tell me the quantity I need to produce, I can tell you the minimum possible cost to produce that quantity. And we'll be using these graphs to do it. But that's it for today. Thanks. Bye.